Welcome, class, and we're going to take some notes over density and some of the built-in necessities that we need to do in order to be able to calculate density. So some of the things that we need to keep in mind are some of the SI units. That means the standard unit of measurement. That's standard throughout the world. So you can see that the standard unit of length is meters. Yes, the United States uses the English system. However, the majority of the world, like 90% of it, uses the metric. We are the oddballs. So when it comes to mass, most of the world uses kilograms. However, again, the United States uses ounces, pounds, and tons. Then you have time in seconds. Just about everybody uses seconds. Temperature, we're looking at Kelvin. Kelvin is an absolute temperature scale, so it makes it so that there are no negative temperatures. So if there's no negative temperatures, then it makes it easier to do some of our math. We do have the mole as the standard amount of something. Okay. So the mole is quite important as well. And in chemistry, we actually celebrate it kind of like math does pi. And then volume is in liters. That means, again, the United States is the weird one with using ounces. So right here is the metric table. Okay, I crossed out the 10 to the 0. However, you can take any of those units on the metric, so meters, liters, and grams, and you can take it up the table or you could take it down the table. Okay, so you need to know these prefixes. Now, anything of these three that you can see are capitalized in their unit abbreviation, their prefix should be capitalized as well. So you need to know 10 to the 12th all the way down to 10 to the negative 12th. By knowing that, you make it quite easy for you to then perform some of the math questions that will be coming up in this chapter. All right, so our three key SI units that we'll be working with are mass, length, and volume. Now, a nice thing that we have, because not all volumes are going to be in liters, you can actually take centimeters and convert it to milliliters because it's 1 centimeter cubed to 1 milliliter. And we'll show you how to make that conversion later in this chapter. Okay, so you can always take the prefixes. So picometers is PMs, milliliters we're quite familiar with, and then gigagrams if you were dealing with something that had quite a bit of grams to it. So with density, we have an equation. It is D equals M divided by V. The standard unit that we'll use for liquids are liters. We like to really stick with milliliters. With a solid, it could be kilograms. However, we also like to stay in grams. We're not dealing with large quantities of something, so that's usually why we're in milliliters and grams. Density is an intensive property, so it actually can help us identify what kind of substance it is. So if you look at this right here, this is called a density column. If you wanted to at home, you could make one of these. When you add the liquid into a cup or a jar or a cylinder, you just need to make sure that you have something that kind of gently adds it. That way you're not actually trying to mix it. So you can see that you have light corn syrup down here, dish soap, then water, then vegetable oil, and then isopropyl alcohol, which is also known as rubbing alcohol. So our next thing that we want to talk about is how temperature actually changes density. So as heat increases, you have an expansion of volume. So by increasing volume, density is then going to decrease. Okay. If you think about it, if it's mass divided by volume, if the denominator gets bigger, our answer gets smaller. So here are the three density equations. You're always going to have this one on the back of your periodic table, and then you can just rearrange it to find for mass or to find for volume. So let's go ahead and let's run through some problems together. So we're going to work through guess. Okay, and guess is just saying, hey, show your work, show your givens, then your unknown, your equation that you're going to use, substitute it in, and then give me your final answer. So for G, it's your givens. So you're given a volume, okay, of 45.8 centimeters cubed. You're then also given a density of 0.5714 grams per centimeter cubed. You're asked to solve for mass. Okay, the unit that we would be using, the only unit for mass is grams. So we're going to use D equals M divided by V. We want to isolate M, so we need to multiply each side by V, giving us M is equal to D times V. So go ahead and substitute those numbers in, and we should get a final answer. Now, your final answer, you need to take into consideration sig figs. So this has 4 sig figs, and this has 3 sig figs, giving us an answer with 3 sig figs. So 45.8 times 0.5714. Then we have 3 sig figs, so my final answer, well, my answer before scientific notation is 26.2. So my final answer would then be 2.62 times 10 to the first grams. And we have solved our first problem of density. Sorry for the interruption. We're going to talk about the volume of a metal cylinder. So we're going to go ahead and let's see. We have the density. That's equal to 11.8 grams per milliliter. And we have the mass, which is equal to 28.76 grams. Okay, we're looking for the volume. So we're going to still use the density equals mass divided by volume. In this one, since we're looking for volume, density and volume will switch spots. You get volume equal to mass divided by density. Plug those numbers in. You'll have 28.76 divided by 11.8. Sig fig wise, this has 3, this has 4, so your final answer can only have 3, giving you 2.444, and that would be milliliters. The only unit left for volume is milliliters. All right, let's talk about the last slide for these notes, and that is just some of the derived units. Okay, it's just a good list that you might want to look at and how they are found. Okay. Hey, that was density for chapter number 2. Go ahead and try that worksheet and ask any questions that you have.